Okay, so we're working on correlation, and we've observed some data here. What's written in black is shoe size versus the forearm length of a human being. Okay, this is just randomly collected data. We have, what, 8 pieces? What we're going to do is we're going to set up a scatter plot because there are 2 variables here. What are the variables? Exactly. Now, we talk about X and we talk about Y usually when we're plotting things. Now, when we go to plot something on a scatter plot, what we try to do is we try to put the independent variable on the X, independent, and then we try to put the dependent variable on the Y. Excellent question. Now, this is for things when we're quite sure of a type of relationship. Okay? It's specifically something called a causation relationship. Okay? So, for instance, maybe a good relationship would be if I was throwing a baseball. The more force I put into the ball when I throw it, the farther the ball would go. That's pretty logical when we think about something that has a causation relationship. Now this one here, shoe size versus forearm length. Are we able to say that one causes the other? It may not be a weak correlation.
Sort of.
Would you say that because your shoe size is bigger, therefore your forearm must be longer?
Would you say that your forearm is big?
Or yeah, could you say the opposite? That because your forearms are large, your shoe size must be large or must be small?
Yeah, that sounds
We can't logically choose one over the other. Okay? There's probably a correlation, and we're going to talk about that in a sec, but we can't choose one over the other. So what we're going to do is we're going to make a hypothesis. We're going to guess. We're going to go out on a limb and say, you know what? We think shoe size causes the forearm length to be longer, and that's how we're going to set up our data. So we're going to call shoe size our independent. It's not wrong to do that. This is our guess. This is our hypothesis. Just like you guys done in science, we're going to test something. So in this case, we're going to call the shoe size the independent variable, and we're going to call the forearm length the dependent variable. Okay? That may not be the case, and what we're going to do is try to figure this out and then think logically about the information we've been given. So we set up our graph here, and it looks like shoe sizes range from 1 to 15, and forearm length ranges from 1 to 14. So 2, 4, 6, 8, no good. So I'm going to have to go up by, I'm going to make this graph a little better here, sorry. Drag this down a bit. I'm going to go up by values of 2, hopefully. 2, 4, 6, 8, 10, 12, 14. Yeah, that's about good. Okay, so we'll make this graph our dependent, or our y will go up by 2, and we're going to do the exact same thing on our x-axis here. We have 2, 4, 6, 8, that's not an 8, 10, 12, 14, and 16. Okay, so we're going to take the data we've taken from above here, and we're going to plot these points. Okay, so the very first point is at 3 and 5. Now remember we said that our shoe size was going to go on the x, and that our forearm length was going to go on the y. So I'm just going to write that down here, shoe.
Seriously, on test, can we choose like 2 or 14?
Yeah, we're going to have to, you'll have to take every example differently. You'll have to look at them independently, okay? So this is a specific one we've talked about now. 3 and 5. So plotting the data shouldn't be too difficult. Our shoe size was 3 and our forearm was 5, so I'm looking at 3 and 5. I have a point here. The next piece of data I have is 5 and 4. So I go up to 5, up to 4. Okay. Next piece of data is 2 and 2, which would be right here. 10 and 11. 12 and 11. 8 and 9. 1 and 1. And 15 and 14, which would be here. So, the first thing I want you guys to look at is the way that the scatter plot is set up. We're going to be talking about putting in a line of best fit. Do you think that there would be a line of best fit or an imaginary line that would kind of model how this data is going?
Yes.
Yeah. Yeah, it looks like we have a line, and I'm going to estimate it for us here. And we're going to say that it probably looks something like that. They all roughly fall around that line. Now, they may maybe not all fall exactly on the line, but they're around there, okay? So we have what would be considered a correlation, okay? Now, this is called, what is it, Paulo? What type of correlation?
Positive, strong correlation.
Yeah, this is positive, okay? Positive because the slope of this line is positive. So you guys got to think back to your grade 9 stuff. Positive is heading in this direction. If I had a correlation like this, the second one here, I'll change the color, so the blue one, what type of correlation would that be? Negative, that's right. Okay. So this is a positive correlation, and are they roughly all clustered right around that line, would you say? Because they're pretty close to being exactly on that line, we call it a very strong correlation. Okay, so this would be a strong positive correlation. Now, just because there's a correlation, it doesn't mean, remember we were talking about this at the beginning, that this is a cause and effect relationship. So yes, a positive strong correlation. Okay, positive strong correlation. Now what we want to do is I want you guys to think about cause and effect. Cause. Okay. So, remember we were talking about this at the beginning when we were thinking about our independent and dependent variable. Does one cause the other? So, from the data, we have a positive strong correlation, but does that mean that your shoe size causes your forearm size to become larger? From the data, you may guess something like that. But when you look at data and statistics, it's very important to use logical thinking. Okay? And think about it. If my shoes grows, does that mean my forearm has to grow? It doesn't cause it. Because my shoe's growing, it doesn't mean my forearm is going to grow. Right? And the reverse isn't technically true. So yes, there is a correlation here, and it is very strong. But there's other things that can cause correlations that aren't cause and effect. A, we could just have a coincidence. What would be a logical reason to why this is a strong correlation? Because you grow. And as humans grow, what tends to get bigger on them? Their arm lengths and their shoe sizes both get bigger, right? Okay, so like we said, this doesn't mean that there's a cause and effect. But let's talk about something that may be cause and effect. Now, we don't have any data for it, but I just want to speak about this. Let's think about speed a car is traveling versus braking distance. Okay? So, I'm going to talk about these out loud, and I'm going to kind of sketch a model on a scatter plot what this might look like. If we're driving in a car, okay, and I'm going to put speed as our independent variable because we are controlling the speed, and most likely our braking distance is dependent on the speed of the car. So I'm going to call that my independent, and I'm going to call braking so as I increase in speed, so let's say I take a study and I measure many different events of one guy driving in a specific car. And I notice that as his speed is increasing, that's right, it takes him longer and longer to brake the car to a full stop. Okay? Again, this is considered a positive relationship, and it's probably very strong. And this would most likely be a cause and effect relationship. The faster the car is going, the longer it takes to brake, right? Just simple as that. Because I'm going faster, it's going to take my car much longer to slow down, no matter how good my brakes are. Okay? So that would be an actual cause and effect relationship. Always think about it. Both of these had strong positive correlations, but one of them wasn't technically cause and effect and the other was. So we have to use logic when looking at stats. Now there are two other ones that I do want to talk about, and I'm going to just draw rough sketches of them very quickly. So here's one graph, two, actually I might draw three. Let's say I have a relationship where the dots kind of look like this. Okay? Now this type of relationship would be considered a negative relationship. Okay? But if you guys notice, these aren't as clustered around that line of best fit. They're a little more spread out, which means it would be considered mild or moderate correlation. Okay? So we call it mild negative. Very good, because it's in a negative direction. Let's say I have something like this. Can you fit a line of best fit through this? There really isn't a line of best fit. Whether I drew something like this or like this, they would be equally likely or unlikely. Okay? So there really is no correlation between those. So this would be considered having no correlation. Okay? So if we take two sets of data and we plot all the points, this data would have no correlation. Mild negative, no correlation. I think that's all I actually wanted. The third graph wasn't that important. So,